Let's look at one of the challenges for TAMUCtf, in particular Leaning Tower. It was in the crypto category, but I don't think it was much of a crypto. So let's look at the challenge. So the challenge was find method of input and figure out what the right input is. Reverse engineering it isn't a bad solution, but I wouldn't spend all day at it. Are there any other ways to possibly exploit this? Hint, the flag is 14 characters long, acceptable characters, and yeah, the whole list of characters, and the flag is in the format flag, curly brace, and some characters. Yeah, so I did solve it by using reverse engineering, so I guess the advice wasn't that bad, but let's look at it. It has some quite interesting tricks. And let's look at them. So let's start by running the program, and I have my virtual machine here with the program. So let's look what I have. I have some patched version, but we'll use the regular one. So it was Windows executable. So that's also not very often, or maybe not that uncommon also, but yeah. So when we start the program, it just ends and nothing happens. So it might be that it detects that it's being run in virtual machine, or this is the part of the challenge that what was written in the description, that we need to find out the source, how we can input the flag into a program. We could also try passing some values as an argument, or maybe more, but it looks like nothing works. So let's look at this exe file in Ghidra. So I have it here. Let's open. I already have it analyzed, but I will try to explain step by step what might be the understanding and solving this. So let's look at the function, and we'll have entry, or in this case WinMain. Already have it, I think, renamed, where we start, or where we can start our analysis, and there's like a standard WinMain with main being called here. So let's just go there, and if the main gets decompiled, we can actually see some interesting stuff. So first we load the ntdll, and then of course we check if we manage to do it, and then we get an address for anti-query information process. That's also an interesting function. It allows us to query some information about the process, which is indicated by the name. And a bit later, this method is being called with some arguments being passed. Here it's like those arguments. So handle, we have a handle to current process. We have some 7, which is identified as this, 4 and 0 are being passed to this method. So we need to find out what actually is being called here. So if we go to information about this function, anti-query information process, we can get the signature. So we could actually maybe apply a little bit of those information, maybe rename the variables. But what actually is interested to us, so the first is process handle. So we can see, okay, this is the process handle. The next we pass value of 7. So let's see what this 7 is equal to. So if we check, the next is this process information class, and we have some enum values here. And if we look at 7, we are querying about process debug port. Retrieves at word pointer value, that is the port number of the debugger for the process. A non-zero value indicates that the process is being run under the control of ring-free debugger. So there is some kind of debugger check here being done. So if we will be debugging, we need to be careful, because this will detect that we are debugging, and it will go to exit directly. So this is basically anti-debugging trick, and we will later use that to prevent detecting that will be debugging this process. Okay, if we move later, we can see a call to open clipboard, which is actually, so maybe that's the way that the data is being pass to this program. So it has to be in the clipboard, and this is, I must say, quite interesting way of passing information to the binary. I'm not sure if I haven't seen something like that, but I guess, yeah, anything is good. So at least one, I guess we can assume that one answer to the questions in the description we already have. So the input method is by copying the text to the clipboard, and we can see later this is called to get clipboard data with cf text. So we are interested in text data from the clipboard, and then we just copy that data to some buffer in the application. So let's just actually try if what we just found out works. So we could debug it in VM, but I wanted to try something else, and I wanted to not spend time in the VM, although the VM will be working, but I want to use my debugger in the host machine. So I will just use the WinDbg in the virtual machine to run as a server, and then I will attach WinDbg in my host machine to that server. So to do that, I will just start a WinDbg session here. I will open the program, not that open. I need to open executable. I will pass the program, and the program starts and it breaks. So now I need to just write server, and I want to expose it by TCP on port. I'm just looking at my notes, 505, and it says, I guess I'm already debugging it on that port, and yeah, I didn't close the previous one, so let's just close it and do it again. WinDbg, again, open executable program, and let's server TCP port 5005. Okay, and now it says that we need to connect remote with similar arguments, and I will just minimize this and open here. I also already have this, but from the new WinDbg we can connect to remote debugger. We pass the TCP server, its name of the server, and the port the same as we saw in the server command. And then when we hit OK, it will try to connect, and yeah, it did connect. So right now, how we can break in the place that we are interested in. So we know that this anti-query information process is being called, so let's just break there. Anti-query process. And we also know that open clipboard is being called. Okay, it doesn't know yet that function, but it will, yeah. Anyway, we have a breakpoint here. And also let's put something in the clipboard so we know that something will be found if we create a new one, and A, B, C, D, E, F, G, H, I, J, K, L, M. That gives us 13, so that's 14 characters, and let's just copy to clipboard. Okay, that's done. And now we just run G, and we get first call in anti-query information process, but we don't see anywhere on the call stack our program. So it's, I guess it's some kind of internal before the actual application starts. So we just hit G again, and we get another one and another one. We just want to see some of our program on the call stack, and we see here. So this is the call, and we can verify by going one stack up. We can see this is the call. We see similar like 740 that we saw in Ghidra. So this is the call ESI, and this is the check that's yeah, that the value being returned by anti-query information process. So let's just put a breakpoint here. So I don't know why it doesn't want to put a breakpoint, so let's just do it again. Okay, so I found out why I couldn't put a breakpoint. Apparently F9, which is put a breakpoint on a line, is also a shortcut for pausing the recording. So actually I pause the recording and talk for 10 more minutes without being recorded. So let's just get back to our program and try to understand what's going on. So we finished with this test EAX, which was a call to anti-query information process. And in this EAX, we'll put a breakpoint now. So let's hope F9 will not stop the recording now. So we have a breakpoint. And now when we just continue, we'll get this breakpoint hit. And in EAX, we'll get the result from the function. And even though I'm debugging, I'm getting all zeros. And if I have a 0, actually it will go to the exit. So I'll just modify this value to something else, non-zero, so I can pass this check and go further. Okay, let's just maybe not use shortcuts, so let's just step over a few lines. Yeah, so we passed the check for the debugger port. So now we should get to our call for the open clipboard. And this is the call to open clipboard. Actually, I'm not sure if I have anything in the clipboard right now because I had before. So let's just make sure that we do have something in clipboard. So let's just put the same A, B, C, D, E, F, G, H, I, J, K, L, M. We have 14 characters, so let's just copy them to the clipboard. And now let's just go past open clipboard. That work, and here we will have get clipboard data. Okay, and now if we display the ESI register, the data at this address, we will see our clipboard data. So we managed to identify how the data is being passed to the program. It's via clipboard. So that's one part of the mystery. So let's find out what's happening with this data later. Okay, so let's get back to Ghidra. So we are past this point, get clipboard data. So later we just we just log the data and copy it to some other place. And if we scroll further, we can see something interesting. We have one string, second one, third, fourth, fifth, which look like some kind of hashes. And we can also, looking at the structure of the code, we can see that something very similar is being initialized here. So we have like 4 lines that looks similar to those 4 lines and those 4 lines, and so on and so on. And if we like scroll and count them, we'll find out that we have actually 14, which is the number of characters that our password or our flag should have. So that might give us an idea that okay, those hashes somehow are connected with characters of our password. But if we would try to check all the hashes for all the one character values, we wouldn't get anything interesting because it's not that easy. It's not that easy that those values are hashes for each characters. So we need to analyze it further. And if we go further beyond those hashes that are being defined here, we can see a while loop, and actually it's already a bit easy to see here, but we have a call to each letter of the password, and I already marked it as SHA1. But if we go into this function and if we go even further, And even further, we can see here that we get some some calculation, which actually, if we would find out, those are the SHA-1 calculation for characters of the flag. So we have the SHA-1 calculation being done here. So that's gives us something, and we just need to find out how this is used for the flag comparison. So if we go to our while, so we calculate the hash here, and we have a hash, but then it's being converted even further. Because if we go to the second function, we pass this hash, and each character of the hash is being converted even further. So it's actually 2 hashes are being passed here. And for both hashes, we take each character, we convert to the value of the hex digits we have in this hash. So if we have like a 0, so ASCII 0, it will be converted to like decimal 0. If we get A, it will be 10. If we have F, it will be 15. And this is converted in those lines. And we have the similar calculation for the second hash. And having those 2 values, we XOR them here. And based of the XOR result, we take 1 hexadecimal digit from this string that contains all the hexadecimal digits. And for all the characters we do, so in the end we get a new hash, which is generated from XORing each digit of those 2 hashes together and generating new values. So this is how those hashes are being converted. So they are not like taken as hash. We just need to convert them a bit further. And then after those conversion, it's being compared to the ones that we saw in this list. So this is hash for the first letter with XOR. This is a hash for the second letter with XOR. This is for the third, and so on and so on. And the comparison could be visible here, which is just comparing byte by byte, going through all the bytes of the hashes. And after one round, the previous hash is used for the next letter as the one of those 2 hashes to be used for the XORing algorithm. So it's like being passed from one letter to another, and then in another round the next one is being used. But it might be easier to understand just in a moment looking at the Python script. So let's just see at that Python script that can solve us those hashes. So those are the hashes that we can see in Ghidra. Here, those are those, and we have this previous one, which is called previous here, and this one is the one we can see here. This is special. This is where we start, and those will be used for next letters. And I have some helper functions. So value will just convert a value of hexadecimal digits to integer. Then the XOR is doing the same as we saw in Ghidra. So basically, based on the XOR operation, we take one of those hex digits and we just do it for all the letters in the hashes, and we return a string. And we have our alphabet of all the possible letters that this flag might have. And just for all the hashes, we XOR the current one with the previous, which for the first round is this one. And then for the all letters in alphabet, we compute a digest. We could actually store those, not to calculate all the time, but I guess it's not that complex. We have only that many letters. And then if the digits matches, we just add this letter that we calculated to the result, just print that we found something, else we didn't found it, and we just for the next iteration, previous will be the current iteration actual hash. And then at the end we print the result. So let's just see if that works, or what we'll get. And we got, okay, that we found flag, curly brace, and nice job. So that's the flag based on those hashes. And let's just see if that actually works. So let's just get back to our machine, virtual machine. Let's just write flag, nice job. Let's just copy that to the clipboard, and let's just stop our WinDbg. Let's just run here, program exe. Yeah, we got winner. You should know the flag now, and yes, we do know the flag because the flag is nice job. Yeah, so that's it for the leaning tower. Yeah, not sure if that was a crypto challenge. It was kind of nice, nice way of passing flag to the binary. Not that difficult. Once you know how the hashes are being changed, it's fairly easy to write a script and to retrieve the flag. It was also a bit easy that we knew that the flag starts with the flag, so those 5 characters we could actually check quite easily if they produce the correct result with the hashes. So yeah, that's all for this challenge. Yeah, I hope it was interesting and you liked the video. If so, please like and subscribe, and see you next time. Bye bye.